So in chemistry, there's this thing called standard atomic notation. Let's talk about it. The notation contains the symbol, written as the letter or series of letters off the periodic table. It contains the mass number, which is written superscript on the left-hand side of the number of the symbol. And it also contains the atomic number, which is written subscript, which means below, also on the left-hand side of the symbol. So here's an example. Let's find the number of protons. So if the atomic number is 35, the atomic number equals the number of protons. So we just write 35. If they asked us to find the number of neutrons, we need to remember this formula. The mass number equals the number of protons plus the number of neutrons. So if I subtract the number of protons from the mass number, I should get the number of neutrons. So the mass number is 80, because that's the superscript number. The number of protons is 35, because that's the subscript number. So 80 minus 35 will get me 45 neutrons. Next, if they ask us to solve for the number of electrons, we just need to remember that the number of protons equals the number of electrons. So that's also 35. And if they ask for the atomic number that's given in the example, you just need to know where it is. It's the subscript number, also 35. And the mass number is the superscript number above. It's given in the example, so that's easy. It's just 80. Okay, let's do another example. If an element has an atomic number of 34 and a mass number of 78, what is the number of protons, neutrons, electrons, and its complete symbol in atomic notation? So I like to put a placeholder for the symbol first. I'll just use this box. And the number of protons is the atomic number. So they say that the atomic number is 34, so the number of protons is 34. And I can fill in the atomic number in my symbol. It says that the mass number is 78, so we'll fill that in as well. And we have 34 protons. Now it's time to solve for the number of neutrons. Remember, to solve for neutrons, all you need to do is take the mass number, 78, and subtract it from the atomic number, 34. Of course, I have 34 protons because I also have 34 electrons because I also have 34 protons. Back to my neutrons, we just need to subtract 78 from 34. That is the total number of protons and neutrons subtracted just from the number of protons, which will leave us with 44 neutrons. So to find the complete symbol, all we need to do is go to our reference table and find out which element has an atomic number of 34. And that is Se, selenium. Very important micronutrient found in things like mushrooms. Next, if an element has 91 protons and 140 neutrons, what is the atomic number, mass number, number of electrons, and complete symbol? So here's my placeholder for my element. I have 91 protons, which tells me my atomic number is 91. If I want to find the mass number, all I need to do is add the number of protons, 91, to the number of neutrons, 140, and that will give me 231 for a mass number. Of course, I also have 91 electrons because proton number equals the electron number. And last, what we need to do is find the complete symbol. So we have two numbers to go off of here. We could search for which element weighs 231, or it could search for which element has an atomic number of 91. You always want to go with the atomic number. Some element on the reference table might weigh 231, but there's these things called isotopes, which could make an atom that doesn't normally weigh 231 weigh 231. You'll get the answer wrong. So if you want to be right every time, go on the atomic number. There's only one element in the world that has 91 protons. You go and you scan till you find 91. There it is at the bottom. And Pa, protactinium. I don't know anything interesting about protactinium, except it's the answer to that question. Okay, let's do another one. If an element has 78 electrons and 117 neutrons, what is the atomic number, mass number, number of protons, and complete symbol? Well, if I have 78 electrons, I also have 78 protons because electrons equal protons. So if I have 78 protons, that means my atomic number is 78, and I can fill that in. If I want to solve for the mass number, all I need to do is add the number of protons, 78, to the number of neutrons, which is given in the problem, 171 or 117, and I will get 195. And last, you just need to go in again and scan your reference table to see who has an atomic number of 78, and it's platinum, a very valuable and expensive metal. Okay, so atomic notation is kind of like a shorthand method for denoting an element's symbol, atomic number, and mass number. If you have knowledge of what these numbers mean in the notation, and you also have memorized the formula, mass number equals protons plus neutrons, you should be able to answer any question about the notation. If you have any questions on atomic notation, please let me know.